Okay, now some hints, because these are pretty challenging questions, okay? First of all, let's identify the doubling value of our function f of x. So, can you identify the doubling value of the function f of x? You should stop and see if you can do that. Okay, you should have stopped and thought about whether you could do that, and maybe you've already done it. And if you've already done everything, then you probably don't need this hint. And incidentally, this hint is just applied to this problem. And this discussion is applied to just this problem. So to identify the doubling value, we already know that g at this value of x, whatever it is, we haven't even given it a name, is double the value of f. So that this y value here is twice as great as this y value here. Now, can you use that to identify the doubling displacement for the vector, or for the function f of x? You should stop and think. Okay, now if you haven't done so, too late. Well, not too late. You can still stop, but I'm going to go on. Okay, so well, if this is double this, then all I have to do is go over here and project down here, and I can draw an arrow if I've done that accurately, and of course I probably haven't, but if you have construction tools, you can certainly do it accurately. So this looks like my doubling displacement. Now, if I do the doubling displacement, and again, and even again, well, I'm going to go off the edge of the graph fairly quickly, but of course I can move backwards this way. It appears then I'm going to get a series of points on the graph. The point directly above here is going to be here. The point directly above this, well, it's going to be way up here someplace. Point directly above here, of course, now coincides with the point A. The point here might actually be on the y-axis. The point here, maybe here, and maybe here. Now what I've got is several points at each of which, and of course I didn't mark this one, the y value appears to double, of course, compared to the preceding. Now I haven't drawn the graph with complete accuracy. This really doesn't look like it's double this. It's pretty low, so I kind of screwed the graph up when I drew it there. I should have been steeper. But still, we have now a set of points, and at each of these points, the value of g of x has to be double the value of f of x. Now I'm going to leave it to you to think why it has to be double the value of f of x. Remember that at this point it's double the value of f of x, or whatever this x value is. How can we conclude that at every one of these x values here, and I've been a little ambiguous about what I said, at every one of these x values, the value of g of x is double the value of f of x. We can prove that, and I'm going to leave it to you to think more about that. Now that doesn't prove that it's true for all x, and actually to prove that it's true for all x really requires more than you probably know now, but it's still worth giving it 30 minutes of thought. Okay, unless you just, think about it for 10 minutes and fall asleep or go insane or whatever, and that's always possible. Okay, seriously, no, don't go insane. Okay, now we'll address this question, which again can start out fairly reasonable, as this does. It's fairly reasonable to at least understand what I've shown you here and how that connects to the conclusion that at every one of these points, the value of g of x should double the value of f of x. You can't draw that one. Okay? But then extends into something that really needs to probably, it's probably going to take you a couple more years before you can completely answer that. Goes fairly deep into analysis. Okay, that's one hint. We'll come back with a hint for this one.